right? So this is example 10. We're going to actually do twice. First, we'll do it with the algebra, and then we'll look at the graphs. Determine if even, odd, or neither. So again, in order to determine what we're going to do, we're going to take g of negative x. Right? G of negative x. How do I find g of negative x? In the place of x, put a negative x, right? Negative x to the third minus negative x. Okay, but what happens if you take negative 1 to the third power? It's negative 1, right? So that is negative x to the third. Okay, what about this minus a negative x? Minus a negative means plus. Okay, but if I factor negative 1 from both of those terms, I have negative x to the third minus x. Well, that's the opposite of what we started with, right? The g of x is x to the third minus x. G of negative x is negative. G of x. You see that? So when if you plug in and you get the opposite of what you started with, of the g of x, then you say odd. That's odd. Okay, let's try the next one. H of negative x is negative x squared plus 1. So what happens if you square negative x? The negative 1 squared is, it's positive 1. It's the same thing as x squared plus 1, right? But that's the same thing as h of x. So is that even or odd? It's even, right? H of negative x equals h of x, so that's even. Okay. And what you notice the pattern of this first two, right? Both of these terms were raised to an odd power. 3 and 1, and it was odd. For polynomials, this works. This one, it was raised to the second power, and a constant is like x to 0. So if all you have are x raised to even powers and constants, it's even, right? So odd powers, odd. Even powers, even. What if it's a mix of powers? Odd and even. Neither. Neither, because it has one term which would have been even and one that would have been odd.